All right, Precal, let's find all the holes of the following function. And I'm going to write our answers as coordinate points. Let's do this. So, again, the goal should be, if you're like, I don't know, factor. Okay, so the top is the difference of squares. So you see I quickly already jumped to that. That's just x squared minus 4, took the square root of both of these. You got x plus 2, x minus 2. The bottom part we're gonna factor as well, but first I'm gonna take out a 2 because I can, and it makes it a little easier. By the way, if you forget to do this, it's not the end of the world. It's going to be harder to factor. That's all. So x plus 2, x minus 2, 2 over what? Now, as a little tidbit, these are usually cooked up. And so what I usually do is look at the top and say, hey, 2, I see 2 and negative 2 as x plus, I'm sorry, the numerator is x plus 2, x minus 2. So probably one of those is going to work. I'm going to go with x plus 2 because it's plus 5x and plus 6. So I'm going to say x plus 2, x plus 3 because 2 times 3 is 6. And hey, 2 plus 3 is 5. That works. Woohoo! And so x plus 2 divides out, and I'm left with x minus 2 over 2 times x plus 3. And so the one that divides out, that is your hole. So your hole exists at x plus 2. So in other words, when x plus 2 is 0, x is equal to negative 2. And what are we really saying here? We're basically saying that if you plug in 0, if you get 0 on the top, you're going to, and 0 on the bottom, you're going to get 0 over 0, which is called indeterminate, which is not to be confused with undefined. They're not the same thing. But indeterminate means that there is no exact, there's no way to determine what the value is going to be. You run into a problem. So that's why we have a hole. And so what we're going to do now is figure out the y-coordinate. You take the leftover x and you plug it in. And you plug it in. So you get negative 2 minus 2 over 2, negative 2 plus 3. And this gives me negative 4 over 2, which is negative 2. And so this would be the y value. So the coordinate, the hole exists at negative 2. Negative 2. Okay. What am I actually saying specifically here? Let me show you guys. So let me hop onto, Desmos, and let's see. I have a problem here. All right, so this is the original equation. I'm gonna scroll this up a little bit. All right, so there's my original equation. We're gonna type that in. No space. 1 second. So we have fx, y doesn't really matter. X squared minus 4, 2x squared plus 10x plus 12. Okay, so this is the original function, right? It looks like that. Okay. And when we simplify it, we get this one here, which is y equals x minus 2 put parentheses around it because I didn't hit division initially, 2 over x plus 3. Okay. So notice the blue one versus the red one are identical. Can you guess where they're not identical? I bet you they're not identical at the hole, which is negative 2, negative 2. So notice here, use my surgeon hands here. Oh, the red one is negative 2 undefined, which means I have a hole here. But what about the blue one? Negative 2, negative 2, because that's where the hole is. So the idea is that these two equations are the same thing, except the top one has a hole, and that's where we find the hole. And that's why we when we look at this, that's why we plug back into this equation, because we want to figure out, hey, where does that hole actually exist, at what value? Well, if these two are the same equations, except this one doesn't take into account the hole, but we know the hole that x equals -2, well, we can find it. Okay, so I hope that that logic makes sense, so you don't have to memorize anything, and you can just think about it, and the answer emerges, and you win. Okay, all right, see you guys in the next math video.